Hello everyone, welcome to the Mammothon Tutorials. I hope you're all excited to get started. We're going to start off with a short introduction. So first of all, I wanted to introduce myself. I'm Rebecca, I'm the Program Manager for the Mammothon from Encode Club. And I'll be in contact with you throughout the program, and if you have any questions at all, then I'm the person to ask. So just send me a message on Discord or by email, and I'll try my best to help you out in any way that I can. So at Encode Club, we're an education community. We help you learn, build and forge your careers in emerging technology. We do this through educational events like hackathons, public education series, boot camps and accelerators. And we hope those of you who are new and joining us from the Mammothon will stick around in our community as you build and grow, because we're really excited to be part of your journey. So let's talk about the Mammothon. It's a really simple process. You have 28 days to build and ship your projects and be in with a chance of winning part of the $250,000 prize pool. So that is huge. The prize pool is going to be split evenly between the top 10 teams across all idea tracks. Now, this is where the Mammothon is a special event. In the Mammothon, you don't have to come up with your own project concept. There are Celestia Ecosystem partners who have shared ideas on what they want to see built on their tech stack. So they've given you all the resources that you need to succeed. You can build unstoppable apps, you can craft on-chain worlds, and you can upgrade the internet. The last thing to mention about the Mammothon before we move on to the tutorials is that in order to participate, you must be in a team of 3 to 5 devs. If you've not already, please read your emails for information on how to build up your team or how to register the other team members in your team to make sure that you qualify to compete in the Mammothon. When we launch, we'll have over 30 ideas, which means a few more are going to be announced very soon, so keep an eye out for that. And each one comes with a matching tutorial. This is really important. We want to make sure that you have everything you need to start the Mammothon so that you succeed. In these workshops, you're going to get all the essential technical skills that you need, and you're going to have the opportunity to ask questions and clarify requirements with each of the idea partners. Okay, so that is everything from me. Let's jump right in.
Well, super excited to be here. My name is Paco. I'm one of the core contributors for LazyChain, and I'm gonna try to make this as quick as possible because this is more of a origins of us, like who we are. And I'll then let Pablo take on the more technical talk because I know you guys are mostly developers. So yeah, let's get to it. So yeah, basically it's an intro slide, but it's what exactly are we building? LazyChain started basically with the Celestia slots. This is a collection of 2,500 NFTs. I think the project has been pretty successful. We became the pretty much OG NFT for the modular ecosystem and one of the best communities in crypto. And one small issue though is that pretty much our success is something that has made our collection pretty expensive. Each NFT costs $8,000, and this is a small issue because it limits our distribution a lot, and it makes it much harder to grow our community. So sort of out of this idea and the fact that we're very close to the Celestia team, LazyChain was born. I think now there are very little things you can do with your NFTs. Same with something like meme coins, you can just buy and sell. And I think our thesis is that communities want to see this change and want more expressivity. I think that could be pretty good and could be a pretty interesting experiment. And I think, we sort of, to give you guys a quick rundown of our construction, we are a sovereign rollup using Geth. We're using the Astria stack, and of course we have Celestia underneath. So this is why we're building LazyChain pretty much. I think we want to establish ourselves as the central hub for modular chains. I think we already have the community to do this and pretty strong partnerships with Celestia and Astria. We are trying to pioneer new methods of community engagement as well. and sort of like embed like community rewards in protocol, which I think could be pretty good. We can only do this because we are a sovereign rollup, so we don't really have validators, so we can try to pass on most of the value generated to the community, which I think gives people a pretty strong incentive to promote the chain. And yeah, we also want to like focus a lot on consumer apps and drive pretty much like mass adoption, and like, you know, like make it easy to onboard new people. And for a roadmap, we have our button, which is we're building this small lottery that is going to be like very gamified, and I think we're gonna launch pretty soon, which I think could help us like a lot in like go to market. I think in Q1, maybe early Q2, we plan to like deploy the chain, and I think we have some pretty cool distribution strategies in place already, and we're getting a lot of traction and hype. And we're probably gonna do a small eCore Legion pre-sale. We're mostly bootstrapped until now. And I mean, we have pretty solid revenues with the royalties we have from our NFTs, but we might do a small pre-sale as well. And we're also building the Sleep to Earn, which is actually one of our ideas for this Mammothon. So if any of you guys are interested in building that, definitely reach out. But Sleep to Earn is basically what it sounds like. It's like you literally go to sleep every night and you pretty much get paid in tokens, which I think could be really viral. There are some challenges of designing this, but yeah. And for Q3, we want to deploy other native apps on LazyChain, sort of like using Sleep to Earn as an anchor to bootstrap our GTM and bring a lot of people in, because it's something that could become really mainstream and I think has a pretty good shot of being viral. And hopefully in Q4 we can all have a dinner together in Valhalla. So yeah, this is the end for my side of the presentation, and I'll pass the torch on to Pablo for him to explain all the more technical details.
Cool. Thank you, Paco. Yeah, I would like to see you on Valhalla. Yeah. Okay, I'm Pablo. Thank you for having me. I'm a technical leader on LazyChain. I'm a senior developer, and I have been working like 15 years on software developer. And I work on different roles: project manager, senior developer, analyst, DevOps. The last 4 years, I have been working mostly on blockchain development. So today, we are going to talk about some controversial way to implement smart contract, that is PDD and TDD. And we are going to talk about LazyChain architecture, sovereign rollup, and a little theory. I'm going to be really fast on that, and how we work on dev team Lazy. So I'm going to share my screen. Okay, let me. Can you see my screen?
Yes, we can.
I can see your screen, yeah.
Cool. Let me see if I can make it bigger. Okay. Well, today we are going to talk about behavior-driven development and test-driven development. And we're going to apply it to Solidity smart contract. The idea here is to increase collaboration between members, different members or stakeholders that normally they don't work as a whole team. And this is where came the word PDD is expressed or is potentially on that. So what is PDD? Behavior-driven development. The idea is to emphasize to work or collaboration between developer, tester, and business stakeholder. And mostly the idea is that the whole team work as a unite. And for that, we got what we call user stories and scenarios that came to explain what we want to implement. And the normal flow is that someone has an idea, talk to the project owner, keep this idea. The project owner talked with the CEO, and after that, it came this idea of a project, for example, Sleep to Earn, and all those. And later we came to a part that we tried to talk with each others, and for that came all these user stories and scenarios in place in the middle that try to put all in agreement how we are going to work with it. And later, this can be applied to those stories and scenarios can be applied to TDD. And TDD is a methodology not for doing tests and not for coverage, but it's especially applied to software development. And when you want to implement a smart contract or any other code, you can use this technical methodology, but for development, not for testing. So this idea of TDD is just a simple way to do the things. And you normally write a very small failing test at the beginning to see or to try to do the minimal implementation. And after that, the tail will fail and you will going to directly implement and fix that test. And later you can, after you make work what you want to do, to refactor a little the code. And I'm going to talk about user stories that I mentioned in the previous slide. And normally you're going to find like this. As a user, I want to do something, so I can do something. And this is typically what the analysts use to express features and different scenarios and stories. And we are going to see that on this workshop to see how this can help us as developer to feel confidence on what the code we are building on. And the analysts normally use this language, which is called Gherkin language. And it has this kind of way to express these scenarios and stories in a way like express the feature, the scenario, and uses some keywords like given, when, then. Given something, when I do some action, then I expect some result. So this is mostly like we use this language on the analyst side. And here, what we do in LazyChain Dev, normally, like explained before, a product manager, work with the community, select most relevant needs, go to the CEO, they talk, they see the funding part, because we need to fund most of these ideas. And then with the help of analysts, technical leader, UX, all these people gather together and they start doing those user stories, documentation, and all what it requires to make this implementation on the go. And yes, when this documentation is done, a project manager and a technical leader create the task and the plan that will fulfill. So basically, this is all the flow. So, okay, let's go to explain. First, the architecture that we are going to use, and later we are going to use a simple example called lock and unlock on an NFT that is similar to the staking, but with a slight difference that you can earn points directly exactly when you just lock it. So this is the link for the GitHub project. I see if I can, or can you, Rebecca, share it on the chat, please? So if you want, you can clone it and start. So
I'm showing that.
Okay, perfect. So I'm going to now share another screen. Okay, yes, I found it. Cool. Can you see this screen?
Yes, we can, but can you zoom in?
Yeah.
So that we can read. Can you zoom in one more time?
Yeah.
Yeah. That's looking good.
Okay. Let's see if I can hide this. Oh, okay. So this is the architecture. On LazyChain, we want to make a sovereign rollup. There's a difference between L1 and rollups, and the idea here is to obtain certain guarantees on security side and on space size compared to L1. So on L1, we normally got a replicated node that replicate the data that it holds, and the way the transactions came into are like a leader selection on the consensus. So a group of nodes select a leader, and this leader has the ability to select or order or make the order on the transaction. And on sovereign rollup, there's a different on layers that split this into three types of layer. One layer is the data availability sampling, which is where all the information is stored. And in our case, we are going to use Celestia. And the difference between the L1 and Celestia is that on the other side, we got a lot of nodes with a lot of data replicated. And they must agree on how they gonna put on the next state of the state machine. And on difference on using Celestia is that this way of storing the data is not replicated. It's a kind of distributed and a kind of like data sharding. So the idea here is that there are nodes that they consensus each other to select what blocks of the data are going to be stored, and in a way that they guarantee that if one of the nodes are missing on the consensus, the other node can simply take that missing part, reconstruct it, and provide it. So here, the space needed is reduced dramatically. So this is why a lot of data availability sampling blockchain are rising now. The other thing that we take into account is the way that the L1 select those transaction order and how they send it to the other node, that later they accept those sequence of transaction. And we select Astria because they provide a distributed sequencer. A distributed sequencers, they agree on how this transaction are going to do or have a specific order and how they're going to be batched in a decentralized manner. So this is principally the difference between an L1 and a stack composed by a data availability sampling and a distributed sequencer. And on top of that, there's a rollup, a lazy rollup, that is that has the execution part. And this is the flow that we are going to have on our future blockchain, lazy blockchain, that a user is going to connect to a site, and after that, it's going to work with it by sending transactions to the rollup. And the rollup is going to be composed with a smart contract that is going to work, and that is going to work with Astria, which is a shared sequencer, and that is going to work with Celestia, a data availability sampling. So with this work, this way of working, we guarantee some things like the order of the transaction to be the most fairness, and also we want to also have to consume or allow to be consumed a lot of data with low fees. Because if you go to work with on Ethereum and you just make a simple call, it's going to charge you a lot on the fees. So we want on the future that LazyChain has low fees and guarantee some fairness on how the blockchain is going to be used. So this is mostly the architecture on we expect to have on our rollup. And okay, now let's go to, I hope you already download on git clone. So we got here. At this point, you're gonna see like something like this. Can you see okay my screen and letters on the console?
Can you zoom in a little bit?
It's okay.
Yeah, I think that's okay. In chat, can you let us know if you'd like it zoomed in a bit more?
Okay.
I think it's good. I think that should be all good.
Okay, cool. So if you clone the repository, you will have this folders structure. So normally this is a Foundry project that has its configuration file. I'm going to minimize this a little. That will have a lot of configurations and mappings, and that tells how to do things on using Foundry. So and besides that, we got these Git modules that we use to import most of our dependencies. So on LazyChain, we normally use OpenZeppelin or Soulmate as smart contract libraries for most of our development. And of course, we are going to have our source directory with all our code. Normally, we got interfaces separated from the implementations, and we got our test folder with all our tests and the script with the script to deploy things. So basically, we are going to start with like here on the README. If you follow, they say, okay, hands-on to start working. So the initial idea would be to start taking tasks that the project leader and technical leader give us and start working on it. So the first one is going to be user story number 1, which his story it's about to lock an NFT. Now, let me now. Okay. So the idea here on the task is it's going to follow a flow that normally, and I think it's too big. Sadly, it's too big. Well, okay, I'll try to work with this. Okay, the idea is that an analyst take notes and design all these scenarios that we are going to implement. And what the analysts do is normally take a flow, normally an UML flow, and it's describe all the operation and possible path that the information can take on the code. So on our first contract, we are going to first try to understand this flow and see what things the analysts say that we must look for. For example, the analysts define the errors that we are going to look for, the events on the smart contract using Solidity, what struct and data structure we are going to use, the variables and function. But here on this way to define things, we are going to see that it's more focused on Solidity and how to do it. And later here comes the user scenarios where you can see all these things that we talk on BDD and Gherkin language. This is Gherkin language, and I'm going to talk about how to understand this. So we got this flow here that says, okay, I'm a user, I want to just lock my NFT. So the first thing that's going to ask the system is, does your NFT is on the list? Do you ownership? And if it's not, it's going to tell, no, that NFT doesn't exist. But if you are if that NFT exists, it's going to ask you, are you the owner? And if you're not the owner, it won't throw you an error. You're not the owner. And suppose that you are the owner and the token ID exists. That means the NFT exists. It's going to allow you to select the period. But that period could be put it in a way that it doesn't fit the system or what expects the system. So it's going to throw you invalid period. And if it is valid, it is going to, okay, do you have fees to pay? And if the system considers to have fees, do you have fees or have you sent fees? And if not, it's going to throw you an error. And after that, it's going to execute the transaction and update the ownership, especially. So this is the first flow of a series of scenarios that we are going to analyze. So basically, what we are going to do is this that we got here. And I'm going to make it a little more faster, but the analysts give us these specifications where the whole system is going to work like a user. There will be an ERC-7021 contract that the owner owns, and it's going to store it or lock it in a staking contract, and that ownership is going to change. By the time he's going to lock it, it's going to gain points, but these points are going to be from the first beginning, at the moment that he locks the NFT. And after that, later, or immediately after lock, he can exchange those points for something else. And here comes different apps or different other contracts that can do things with those points. One of them is the exchange contract. That is going to simply just consume those tokens, those points, and transform it into ERC20 token. So this is kind of staking contract, but split it in different way that you earn points, and later other smart contract can plug in and use those points. And you can, in that way, lock things and later can use in different things. Like, for example, if I want another NFT token, I can consume points and earn another NFT token. I don't need to, for example, change it for an ERC20. So this way gives you more versatility on things that you're going to use or do on your smart contract. So the analysts provide us with a class diagram which defines all the mapping, address, and everything, and define those interfaces and all the errors and how the data structure is going to be. And that is represented on these scenarios that I showed you previously. So for this first workshop, we are going to try to implement this scenario and we can, if it has time, implement this one too. And after this workshop ends, I'm going to publish all those things if you want to try it. They are different on different branches, so you can try to use TD. So let's go coding. So let's open a terminal. Yeah. And the first thing we are going to do after clone is for build. So we need to guarantee that our starting project can build. Also notice that there's a lot of other contract. This previous contract already working on LazyChain and define a lot of things, like for example, this Lazy20 is our ERC20, which has already defined the constructor, and they have defining the min function to limit some things. And if we go to the Lazy7021, which is an ERC7021, it got a lot of Open Zeppelin utilities that we leverage on, and we define just simply an ERC7021 with certain token limitations on the token cap, and yeah, a name and a symbol that can receive from the external. And we do some sanity checks and all. So this came out of the box using previous works on Lazy. And from the design perspective, we already have this, or our technical leader have already give us the interfaces implementation that is based on those user stories and all. So if you're going to look for the user story, those list of events, you're going to find this event as on the user story is defined by the analyst. And here we got some strat and errors and functions, especially those that we must implement as a developer. So the first things we are going to do is start with our staking test. So if you open this staking TSOL, which is the test file, we're going to find that we got already some predefined things to work with and a setup. And some tests, they are going to use this setup, and some others we are going to define. And if you run the test command, if we run force test, we're going to see that a lot of tests has passed. This is the test on the ERC 7021, Lazy 7021, and Lazy ERC 20. And there's a lot of other tests that, for example, TSOL. And here comes my question. Oh, there's already tests for that? And let's check it out. If we go to the test over here, we are going to see that they are empty. So here comes the TDD action part. So we want to construct this. And if we go to our staking sol, we're going to find the same thing. We got the contract, we got our constructor that is empty. So this is the initial step or the setup for starting TDD. And we are going to start from the beginning. So if we go to our document here on our stories, they're going to have this one. And this one got, like I talked on the previously, it has all our Gherkin scenarios. So these Gherkin scenarios are copied and pasted on every test, and we generate all the tests based on these scenarios. So on our side, as a developer, the analyst and the technical leader already prepare us this to do all things. So let's start with TDD. So here is the first task that is going to be, okay, this test goes to the constructor and it's going to test zero address sanity. So if we copy paste this, which is here's the explanation of the scenario, the NFT address is 0, so that means we haven't set up our NFT contract. So we're going to do step by step, like the analyst suggests to do this. So we're going to do given when and then, and here given I provided an NFT address set to 0. So what I can do is a simple object. This is going to be an NFT empty, so we are going to skip setup for this. Even if it's going to run, we are going to don't take care of that because we need to test the constructor. So we're going to create an empty address. And here comes when I attempt to deploy the contract, there should be an error called NFT address cannot be 0. So here we're going to, from the VM, we're going to expect this this error. And this one is going to be what is defined on the interface, and it's got to be like missing NFT address. And here we're going to use selector. And here we call our staking contract constructor. And the constructor is defined here, and it has some function, the address of the NFT, a reward rate that is going to give us how many rewards we get for every hake the blockchain generates, and what would be the fees to pay for locking and unlocking. So on this one, we are going to use to win 1 point for every block generated, and we are going to use about 0.1 Ether to do this. So here we got our first TDD, and we are going to try this. So if we go to our terminal and we run our test, what's going to happen? Exactly what we expected. The test failed. So this is how TDD works. So you actually make a test to fail because there's no function provided on the constructor. And this is what we expect to. So here on this point, we're going to check for that address. So we got here the NFT address, and we are going to check if this one is address 0, which is one of the things that we wanted to do, or if we want to also add some protection here, it's not necessary, but it's nice to have, I guess. So if the address is 0 or the call length is 0 also, we're going to revert this. And we are going to throw missing NFT address. So at this point, we have just implement on the code according to this test that we provide. So now let's go to the console and run again forge test. And okay, it throws some unused on the side of this. We can, for now, just for avoid the error, and we are going to use it, but we are going to find it later. So just the error doesn't appear because we got a strict on checking things that they are not. So I ran this, and now the test passed. So this is how TDD works, and you are implemented the minimal needed to pass this test. So now we're going to do the second one here. And this is going to be invalid reward rate. So the analyst already told me what is the scenario and what do I need to do and check. So I'm going to write this. And given I set a reward rate less than or equal to 0, look that here the reward rate is defined as uint and signet, so it cannot be 0. And why it's asking? Because the analyst side create a model that can be applied to any coding language, not just Solidity. So this Gherkin language doesn't know which language you're going to use to implement. So it got to be sure some things that work with it. So in our case on Solidity, defining on the input that is unsigned int, we guarantee that that will not take a negative value. And the only thing that we need to check is equal 0. Why equals 0? Because if the reward is 0, the user is going to stay and win nothing. So yeah, he's going to be pissed off. So here on this reward rate, what we are going to do is just first, we already checked this on the previous stage. So in this one, we are going to just check that. And here, what we need to is to create an NFT, because here the invalid reward that we already did. Okay. We got this function that only check the missing address, and we now need to check for the invalid rate. So here I'm going to spec a revert. And I'm going to use the interface. And here is going to be invalid reward rate select. So I'm expected to this one, drop that error. I'm going to call the contract for creating this. So I'm going to take staking. Yeah, staking constructor. In this case, since we already are checking for missing NFT as the first step, I want to avoid this. So I'm going to need to create here as a precondition an NFT token. So here I'm going to use the setup definition, and I'm going to use a new lazy, because since it's a constructor, I need to ensure that everything is correct. I'm going to call this lazy NFT, and going to be its name lazy, and token cap would be 4, and going to be first, I don't know, lazy hash, something like that. Going to have this. I'm going. So now I can ensure that this is not an address 0. I can create it as an address different than 0, but I want to start using my lazy NFT contract. So in this case, I'm going to stake this one. Going to be address. I'm going to test what is invalid reward. So I'm going to put 0, because this is what we want. And I'm going just to make sure everything is working. Just pay the fees. Or actually not pay the fees, define this. So here, selector is taken. Okay. So, okay, now I finish this test. Let's run it. And of course, it's going to fail, because on the other side, invalid URI. Wait, here's an unexpected error. is complaining about this. Okay, there's something on this that is not thrown by the, it's thrown by the lazy NFT that doesn't like this. I'm going to, I think it has to do with, yeah, I think it should be here, IPFS, that one. No, it should be okay. Let's check that. So here, there's a validation, and the validation, look for this. And after that, the path. Oh, let's check if that's okay. Maybe I'm missing something. No, it's okay. This should be a hash. Let's run it again. Okay, there was something, I didn't catch it, but okay, it failed because it's expect to revert now. So this validation on the token side goes well, but now it says I expect that this failed with invalid reward rate, but actually that would not happen. So I'm going to decode the constructor, and now I add another restriction or sanity. So here I'm going to ask for reward rate is going to be equals 0. And if it does, I'm going to revert it with invalid reward rate. Let me check. Yeah, okay. And after that, I'm going to run it again. And the test path. So I actually implement the last one here, which is another constructor parameters. And now it asks for successfully initialization. So I'm going to have all these things that I need to take into account. Looked at as a developer, what I'm only doing is just follow the logic that the analyst and the team works on it, and I'm just simply implementing what the scenario said, and I'm checking it. So the first one is given I provide the valid NFT. I'm going to copy paste this one. I provide an NFT that is valid. And I set the reward greater than 0. I can do it on the constructor when I pass it, and the fees greater than the equal. When I deploy the contract with this parameter, the contract should deploy successfully. So at this point, I'm going to do the staking equals, I'm going to call it new staking to differentiate from the setup. And what I'm going to do, this one, staking, call the constructor, and I'm going to pass this address of the LNFT, and I'm going to provide a valid reward rate that's going to be 1, different from 0, and I'm going to put as fees that value. And after this point, it says, okay, once you got the constructor implemented successfully and the smart contract deploy it, then I need to do some extra validation to be sure that that is. So the NFT address should be set correctly. So I'm going to do an assert here that is going to be this In this case, I can provide a way to call this, call the new staking, and call, I don't know if it has its interface. At this point, we don't have the interface exposed. So what I can only do on this point is just check that the NFT is just created. And I can do that different on even on the previous step. So I can do this like this to ensure this one. I can do it here, and I can ensure that this is not going to happen. And later I can implement here the getter method to access store. And the reward right here, I can do like assert, and this is the new contract. And here I got access to this one because it's defined, and it should be greater than 0. And here I can do the same as, in this case is fees, and it should be greater than 0. Or check it as equals to this value. So until this point, there's something red. Let me check. Okay, it's just. So at this point, I think my test and implementation from the test side is done. So let's test it. And okay, there's something on the code wrong. So undeclare identify. Okay, I forgot to declare this one as staking. And let's try it again. Okay, and this panic because we haven't finished our implementation. So the assertion field here with the panic, I can do, for example, I can use for test. And if you go to the README, you will find at the end some tricks. For example, if I want to run only a test, I can use this trick. And I can see what here is failing. This is the staking test. This is the name of the class that is defined on the class. And the test I want to test is the one which is failing, because I need to trace to be sure what is failing. So in this case, this is the name of the test. Okay. Let's try to see. And one of the good things about Solidity and Foundry, it can actually show you step by step what you are doing. So here is the staking test constructor. It calls the new one. And one of the things is it execute the staking reward rate. And when it says, okay, some assertions are failing, so there must be something here or the fees. And probably this one. So let's check it again. We did it with one, and we call it the reward rate. So I guess there must be something that I'm missing. On the assertion fail. let's go check what is implemented. If we actually implement here the check for reward rate, so there must be something else that is missing here. So let's check it out. I got the address, the reward rate, fees. I didn't set up the fees and nor the reward rate. Okay, so I'm going to remove this. I'm going to set up reward rate equals reward rate. I'm going to set up the NFT address because I already checked it here. The address. And since I already set up the fees, I'm going to set up the fees also. Okay, now as expected this failed, and it was because I didn't set up. And that's how TDD works. So actually the error was okay and was verified by analyzing the stack trace that it was. Now let's run it again. Since we implement those things, we're going to track to see the error. Okay, fails again. So there must be something else that is failing. Okay, it checked the reward rate, it checked the fees. So let's check what else is asserting. Maybe there's something else that is missing here. So there's something on the assertion that doesn't like it. So what I can do is, okay, let's see. This one is the reward rate and the fees should be 0 and are greater than 1. And the NFT address is that. Yes?
Pablo, we do need to
Time?
soon
Okay.
and move on to patch your
Okay. I'm going to wrap up a little, but yeah, the idea here is that you use TDD and look for the errors and tracing and try to implement and fix all the code until it works. So this is a methodology that you can use to do a smart contract, to implement a smart contract. And yeah, that's all. Thank you.